Alright, we're back again for part 2 of my Christmas special when we talk about a very silly project to make flashy lights. So I've got this here sofa. We're just going to test this to see if it works before we go into the programming. So this is the board that I made up. So over here for yesterday's I had this thing that I soldered up. So I just put everything together so that it would be a little bit less fiddly than this. It's only marginally less fiddly than this. So it's not much of an improvement. But now we can run it off this board. We just need a few more wires. Where did I put my collection of wires? Right, here we go. So now the voltage. Here we go. These two are close enough. All right. So now the power is going to come off this board. So I'm going to plug the blue into one of the grounds over here, and because of the way I wired this up, the ground's only ever used on this side. So I'll put that one into there and I'll power it off there. You could just directly link this wire to there, I guess. And then we'll move this one over to here. These wires are not long enough. And then we're going to put that into the 5 volts output. You could just stick it into the 3.3 volts, but that would be boring. So we're not going to do that, because as I said, I'm pretty sure it's fine. So then of course it's taking out more current. So we'll do it out of the 3.3 and see what happens. Should be exciting. So it's going to be 3.3 volts. And then, as I said, instead of this red wire going straight to 5 volts, it's actually going to go to one of the output pins, and so I used 5 and 6. So hopefully this works. Otherwise, it will be very boring. So that's not the power thing; that's the USB port. So plug it in, let the coding start up, and we'll just turn this off. And yes, indeed, we have a completed model with this thing flashing slowly on and off. And after a few things it will start flashing. Dun dun dun. So it's actually doing the other one at the same time, but there isn't another one connected, so you only see the one light. So that was a successful project. So now all we have left to do is to talk just quickly about how it is coded up. So we'll disconnect this thing without damaging anything. So I printed out the source code. People, they do that and they do the things on the screen and then they go through it, and it's kind of like, well, that was kind of unexciting. So I thought, well, we'll just print it out because it's much nicer that way, and it's bigger. So here, this is actually not very well written, so it's it's lacking in generality. It would be quite easy. So I will put a link to the source code so that you can try this, but I'll probably adjust it so that it's slightly more general. So in this case here, it's set up to use only 2 lights, but I do define them at the top with a constant. So there's a constant int set1, which is 5, pin 5. So basically this means that I think set 1 should be pin 5 and set 2 is pin 6, and by set I mean set of lights. So that's just why I named it. So here we have the setup. So all your little Arduino sketches will have a setup and a loop. So I've put these 2 at the top. So the setup just basically does what you would think it would do, is it sets set 1 and set 2, the pins that they are associated with, to outputs. So it's always good to label, to name things. So I'm not going to go through and say set pin 6 to be this, because it's hard to read and I can't change things later on. This way I'm saying set the pin set 2, so I'm giving that pin a name and I'm setting that to output. So that's just what the first bit does. Very straightforward, always like that. And then the next bit is the loop, and the loop just goes through and it calls this procedure. I don't actually know what they call them anymore, like what's the name for these things, routine, whatever. Like I'm a Java programmer, so I normally call them methods, but they're not methods because they're not in a class. So we just call them procedures like we did in the old days. I'm sure they're still called that. It sounds very Pascal. But time to stop rambling. And we're saying smooth flash, so it has a bunch of little numbers that we're passing it in. which we'll get to in a second, and then we have flash and that. So you might be able to guess what they do. These are just basically timing things and so on, and the number of times we do it. So there's two different things, and so we'll go down and we'll look at the flash one. So we might zoom in just a bit more because we want it as big as possible. There we go, that fills up most of the screen. Okay, so flash, this takes two different parameters. The first one is the flash delay, and then there's the number of times we flash. And then we just have a loop that goes through. So we're using a loop, so I goes, in this case I've done it the going backwards way of doing loops. The only real reason I do this is that it's slightly faster to do backwards loops sometimes. Like sometimes there's, I'm sure compilers will optimize things anyhow, but the reason it's slightly faster is that you set up and you read this variable once, and then you're comparing it to a constant all the time. So you start off with I being the number of flashes, you compare it to being greater than 0, so you keep doing the loop as long as I is greater than 0, and then I is decreased each time you go through the loop. So the end result of this line here is simply to do this bunch of code here using, hold on, let's just use a pen. I'm using my multimeter cables to do this. Is that we do this loop number of flashes times, and the loop does basically, first off, sets set 1 to be on, so it sets a high, so it sends out a high voltage through the cable, through the wire to the pin, which will then turn all the lights on through the transistor. And it sets the other one, set 2, to be low. So this just basically says that set 1 set to be on and the other set to be off. And then we delay for the amount of flash delay, and that's going to be in milliseconds. So if we look back at the top, the values that I gave it were 500, so 500 milliseconds, so they alternate for half a second. So for half a second you have set 2 off and set 1 on, and then for half a second you have, because we do another delay at the bottom, there's 2 delays. These are basically the same thing, but the other way around. So in this case here, set 2 is high and set 1 is low. In this case here, set 1 is high and set 2 is low. So they alternate on and off, and that's all that is. So it's pretty straightforward. So if we look back at the top, we have flash for 3 times. So this will take a grand total of 6 seconds to do. Not 6 seconds, 3 seconds to do, because we're doing it 500 milliseconds off, 500 milliseconds on. So that's 1 second and then 3 times. So that's pretty straightforward. And the last one, the last part, the more interesting part, is the fade. And so I actually have, there's two procedures for that, just to go through and explain what they do. So there's this one called fade, and this is the way I should have done things, with a general passing in the LEDs that I want to talk about instead of using a constant. So this is how generally you should do things. In this case it says fade in LED, so that's the pin number of the LED that I'm going to fade in, and that's the pin number of the LED that I'm going to fade out. And this is the fade delay. So this is basically how long I take to fade. So the speed of the fade. Is it going to be a quick fade in or a quick fade out? And here, for some reason, I've gone and done the loop the other way around. So the traditional way is to start at 0 and to go up to here, probably because I'm not using a variable. And so no matter what way you're doing, you're always comparing to a constant. Because comparing to a number is probably at a lower level faster than comparing to a variable value. And so that goes to there. So it does it up from 0 up to, but not including 256, because that's a less than, not a less than or equal to. So we go from 0 to 255, and then we delay for our fade delay, which will be quite small. It'll be like 20 milliseconds or something, and then we do this thing here. So this is the only complicated part that's left. So we're going to use the analog write function. So this is kind of different from the digital write in that we can give it a value between 0 and 255. And if 255 just means that there's full time, it's on all the time, and 0 means it's off all the time. And because you're not actually writing an analog value, what you're really writing is a fast alternating value. So it's alternating between on and off. The higher you go, the more time it spends on and the less time it spends off. And the lower the value, the more time it spends off and the less time it spends on. So if you set it to like a value of 1 in every 256 beats in its little time frame will be on and the rest will be off. And this sort of is a way of faking actually changing the voltage smoothly between 0 and 5. In this case, you're always either 0 or 5, but you're on, but you're either 0. You're not 0 all the time and you're not 5 all the time. You're like sharing the space, and so it looks, when you look at the LED, that like you're fading in and out, but really it's just flickering really, really fast. But at a lower level there probably is some sort of, like, it's not, it takes time to go from one state to another state, so it's not strictly smoothly on or off. So there is some actual intermediate values in there, some intermediate values of brightness, but effectively it's just being on and off. If you don't know how pulse width modulation works, that's what this stuff is. And we'll look at that at another later date in another video. And there's like billions and billions of things on the internet about all these kind of things, so just look them up. That's what Google is for. And so the last thing, this is the thing we actually called in the loop, which is smooth flash. So smooth flash takes the flash delay, it takes the fade delay, and it takes the number of flashes. So flash delay is similar to what we had for the on and off flashing. Flash delay, fade delay is the thing that we're going to pass into fade. So if we look down here, again we have this looping thing, and because I had a variable in here, I've done it the other way around so that you start from the variable and go down, so you only access this variable once in the loop. You can't even see that. So I should tell you there. So the things are flash delay, fade delay, number of flashes. So what we do in this loop is kind of similar to what we did beforehand, except we just call fade, and in this case, so we're going to fade, looking back at the top. The first thing is the LED to fade in, and the second one is the LED to fade out. So we fade in set 1, and then we fade out set 2. So then we wait for a little bit of time. So we have this sort of on state where it's set that way. Where it's a fixed state, so one light will be on and one light will be off, and then we fade them back out the other way. So then we fade out 2 and then we fade in 1, alright, and then we go back to, and when we again do the same thing where we pause for a little bit, and that's it. So it fades in, fades out, fades in, fades out. The only thing that's kind of important is just to make sure everything kind of matches up, as I think I tried to make sure that at the end of the day, set 1 is on. So when you finish this method or you finish the other one, this procedure, we'll just check this, make it fill up, that set 1 is on and set 2 is off. And that way whenever you come into this, set 1, is that right? How have I done this? Oh no, so at the end of this, so set 2 is on and set 1 is off. So if you look at this and you come back in here, so I'm going to be fading in set 1 because set 2 I'm assuming is always on when I start doing this whole thing. And hopefully that's the same kind of thing that I do here. So at the end of this one, so when we finish this loop, then we've left set 2 being on and we've left set 1 being off. So both of them start in the exact same state. They both start with set 2 on and set 1 off. And that way you don't have any sort of nasty jarring effect when you go from the flashing, sorry, go back out. When you go from the hard flashing mode to the smooth flashing mode, you don't go from having one set of lights on and then suddenly fading that set back in again and fading the other set, which was off previously, back out. And that's the only tricky thing with the whole thing. And it's a really straightforward project, but it's fun, and it's a really good way of using your little microcontroller if you want to make some fancy Christmas lights, and it seems impressive. And of course, you can make lots of different lighting effects, and you could take this code, this very simple code, and you could just change these things around. Maybe you want to flash like 5 times, or maybe you want to flash faster, and then you want to flash a couple of times real slow, and then maybe you want to do a fast smooth flash or a slow smooth flash, and you can just mix the whole thing up. And if you're really clever, like later on you did some more advanced things, and you had some sort of input, then you can have input reacting to things. So maybe you're measuring the ambient volume or the noise around you, and so maybe it changes when it can hear when there's loud noises happening, and so the lights could react to things around you, or they could react to like a motion sensor or some kind of proximity sensor thing. Any sensor you have, basically, you could just use this to react, to make the lights react. And of course, this kind of idea is the kind of thing you would do with anything that requires a bit more current than the pins on your Arduino can supply. So yeah, so I'll put the code in the description. A link to the code in the description if anybody cares. And the only thing to remember is that the outputs for the code are 5 and 6. And if you want to change that, that's where you do it. And the other thing to remember is that if whatever outputs you choose, they have to have the little squiggly lines next to them on the board. So we bring it up real close. There are squiggly lines next to 5 and 6, and next to 3, and next to 9, 10, and 11. So those are the pulse width modulation pins. So basically that just means on this kind of board, they're the only pins for which that analog write work. So if you try to do that little trick with 8, it won't work, because the microcontroller can't do that kind of trick on pin 8. So yeah, of course you could do it in software if you're really clever and just actually turn it on and off, but there's hardware built into the chip to do it for these particular pins. And I'm pretty sure that, I could be wrong, that the analog write kind of relies on the built-in hardware and doesn't do some clever thing where if you try some other pin, it does it through software. So yeah, thanks again, and like, share, and subscribe, and whatever, and make a comment or something so that I know what you thought of this. And have a good night, because it's Christmas and I'm going to sleep. So bye!